Welcome to 1 Minute HKDSE Physics Heat. Today's topic will be specific heat capacity and specific latent heat. So firstly, we will review some of the concepts, then we will do one question. Now we have 1 kg of copper here. So how much energy do we need to raise the copper by 1 degree Celsius? So specific heat capacity is a constant measure that gives you the value of how much energy is required to raise the temperature of this 1 kg copper material by 1 degree Celsius. Now we have the concept specific latent heat is about 1 kg of copper in solid state. Consider if we want to change the copper from solid to liquid, so energy is required. Specific latent heat is the constant that about 1 kg of copper that change from one state to another state. And very important, in this stage the temperature is unchanged, so be careful when you select specific latent heat or specific heat capacity. So now here's our question. Jerry has 80 degrees Celsius water and some 0 degrees Celsius ice. How much ice is required to produce 1 kg 0 degrees Celsius water? Given specific latent heat of fusion of water is 3.34 times 10 to the power 5 joule per kg, while the specific heat capacity of water is 4,200 joule per kg per degree Celsius. Hint: in this question, you can consider the energy released during change of state is same as the energy required to lower the temperature of water. Before we start to do this question, let's think of something first. Firstly, let m be the mass of ice required and 1 minus m be the mass of 80 degrees Celsius water required. So now first we need to write this statement. Assume no heat loss to the surrounding, as this worth 1 mark in the marking scheme. After stating the assumption, we can write Q in equals to Q out. That is the energy given out by the 0 degree ice is the energy required to lower down the 1 kg degree is the energy required to lower the water 80 degrees Celsius water. So after we have Q in equals to Q out, we can write plot in the equation for latent heat and specific heat capacity as mL equals to mc delta T. We should note that in this question, what happens is that there is 80 degrees Celsius of water, so we want to turn it to 0 degrees water by melting some 0 degrees Celsius ice. So the resultant amount of water would be 1 kg of 0 degrees Celsius water. So by putting mL equals to mc delta T, this is the energy change in this question. So we have m times 3.34 times 10 to the power of 5 equals to 1 minus m times 4200 times bracket 80 minus 0. So after solving we would have the answer for this question. This question is relatively simple and really a standard question in HKDSE Physics MC. After doing all those mathematics stuff, we would have m equals to 0.501 kg. And some of you may wonder why when we would need to net m and 1 minus amperes. In this question, it's the resultant in this question resultant water is 1 kg, so we don't actually know what amount of ice and what amount of 80 degrees Celsius water we are required. So this really the end of today's video. Thank you for watching, and please leave comment for suggestion. If you found this good, please recommend it to your friend. Once again, thank you.